14. Okay, got 10 people here now. So I'll just be completely honest, I've been extremely busy with the debate championship, our SolBridge debate championship that started last night. It's been going on. I hope you guys noticed that, and if you wanted to join, that you did. So I did not have a chance to update the My SolBridge event page to post the questions, also to adjust the topic, because as I mentioned in class, but again, did not update there, that we are going to be talking about solving quadratics. So quadratic formula and sum product method and completing the square and that kind of stuff. Excuse me, that kind of stuff for how to solve quadratic, solve for an x in a quadratic equation. So that's the plan for today. That's the plan mainly because the visual recognition of sort of slopes and such, or what we were talking about in class this week. Not to say that you knew all of it in advance, but it's not really a whole lot of practice. Like, we don't have to go through 20 practice questions with them. You just kind of look and then count how many ups or downs. It's sort of fairly straightforward, I think. That said, if anyone here has questions about that stuff, the graphs and turning points, maximums, minimums, intervals of increase and decrease, any of that stuff, if you want to ask right now, let's do that. I don't think that will take too long, and then we can talk about the quadratic stuff. Where were we? This example, I guess, was the most complicated one that we had. So from class, anyone have questions about this, things they didn't understand, things they want to ask more about?
Sorry, Professor Corks, I have one question.
Yep.
I want to know about the exponent. I mean, let's say that x in the exponent of n. So the n is the maximum number of x-intercepts?
Yes. So we'll do it with this example here. Where's my writing tool? Okay, so for this function, we see, okay, let's look down here, right? We see this exponent is a 5, x to the exponent 5. Let's start with an easier one, actually. Let's say the graph of y equals x squared. It looks like this, right? It's just this kind of bowl shape or U shape. Or it could be flipped upside down and be this sort of arch shape. So if we draw it here, obviously there are no x-intercepts. If we draw it here, there could be just exactly one. It just kind of perfectly touches the x-axis, then goes up. And if it's somewhere down like this, then it just touches 1, 2 times. But there's no way to make this touch the x-axis 3 times. So it's 0 or it's 1 or it's 2, but it's not going to be more than that. There's just, it goes down and then it goes up. It doesn't go down again later. It's impossible for that to have more. An x cubed graph. So x cubed can look like this with 1 intercept. It can look like this, where it kind of goes perfectly flat and then goes up. Often, however, it will look like it'll have kind of an up, down, up, like this. Sorry, 1 second. Just need to mute all my alerts. That's good. And back. So like this, up, down, up. So in this case, touching the x-intercept one time, it could do this and perfectly touch and then go down and then go up. So that would give us 2 intercepts. That's possible. Or it could go kind of over and then back and then over again. There's 3. But just like think visually what this looks like. There's no way to make it cross 4 times. This kind of function just goes up, down, up, can't cross 4 times. So there's a more formal mathematical proof, but from that we can see that the exponent, whatever the exponent is, if it's a 5 or it's a 3, so here it's a 5, that is the maximum number of zeros, maximum number of x-intercepts, and it also is the maximum number of intervals of increase or decrease. So up, down, up, down, up, that's 5. It can't be more than 5. So that's how we can read that number. And then based on that, the turning points, here we have maximum, minimum, maximum, minimum, 4 turning points. The exponent is 5, so 5 minus 1, maximum 4 turning points. And there are more things too that we can notice, but we kind of need to talk a bit more about calculus and to be able to understand inflection points. So lots of patterns. Any follow-up questions from that, or does that make sense? We're good. Okay. Anyone else have questions about functions like this and their patterns? Okay, not seeing any questions. So let's stop that and hop back over here. So factoring and I guess solving, 2 different things. Factoring and solving quadratic equations. This is not kind of a formal part of our class content. I expect most people to know this. The examples we will be having in class are really not going to be that complicated. The simplest method, the sum product method, will work pretty nicely for most of them. If not, we could use quadratic formula. But there are lots and lots of ways of solving these. So we'll talk a bit more and go over some of the other options. Like I said, a little busy, didn't have time to kind of fill in all the details and post this on the classroom page and stuff. I'll do that after class, but I have the rest of the slides ready. So we'll talk about quadratics, and another name is just kind of a trinomial, which I'll explain right now. So trinomial, again, nomial, that just means kind of the parts or the terms, and then tri just means 3. So 1, 2, 3 parts like this. All right, so that's what we're talking about. And let's try to see how we could factor them and solve for x. So let's say we have something like this, and we want to solve for x. So what could we do?
We can move c for the next side of equation.
Okay, so ax squared equals -c.
We can divide by a.
Okay, so x squared equals negative c over a.
And square root.
Square roots. So x is equal to plus minus square root negative c over a. This, you might be seeing the negative c here and say, hey, that's not going to work with square roots. First, it does. It could just be I, sort of square root of -1. Also, we don't know what c is. C could be a negative number, and then the negative in front turns it into a positive. So, or a could be negative. Okay, so that's pretty easy. What if we have something like this? How can we solve for x?
You can divide two sides by x maybe.
Okay, so divide both sides by x, which will give us ax plus b equals 0. And just kind of note here, like kind of by the way, x could be equal to 0. That's one of the solutions. If both of those are, if x is 0, both the terms are 0. So that works out. And then what?
X equals negative b divided by a.
Okay, so this is also a pretty easy situation to deal with. So I didn't mean to write divided by a. Next term, next line, x is equal to negative b over a. So solved. Look at that. Look how clever we are. Those are both pretty simple situations, but it gets more complicated when we have this. If we have an x squared and an x and a c, a constant term all together. Any two of those is fine. If we didn't have this thing and just bx plus c, also very easy. But if we have all three of them, things get more complicated. So we'll come back to this most complicated version a bit later. But for now, we'll kind of start with some simpler ones and then work our way back to this ax squared plus bx equals c type. Okay, so we'll start with this kind of thing, and let's just say we don't have a coefficient here, or we do, but it's just 1. That makes things a lot easier. And then again, we'll get back to seeing what we could do if we do have a coefficient, but it will make more sense if we don't start there. So let's think about what happens if we have something like this and we expand. So x plus m and x plus n, where x is our kind of variable, and then m and n are just some constants, could be whatever based on our problem. If we are going to expand this thing, how do we do that? Sorry, two people talking at the same time. Let's try again.
X squared
Okay.
plus nx plus mx plus mn.
Plus mx plus nx plus mn. So we take the thing, each thing on the left times each thing on the right. So this times this, this times this, this times this, and this times this. So 4 different kind of operations to do, and we get those 4 parts. And if we were to simplify this a little bit, what could we rewrite this as?
X squared plus x bracket m plus n.
Okay, m plus n x
Plus mn.
and then plus mn. So we can just factor out the x here. So an x squared term an X term and an MN term. So what I want you to notice, the pattern here that we will be making use of for these solutions is we had M and N here in the binomial form, the X plus something times X plus something form. And then when we got to here, it's M plus N. So we take the two constants that we had, we add them together, and that will give us the coefficient on the middle term, the B value. And then we multiply those two things, excuse me, the same two things together, and we get the C term here on the far right side. So that's the pattern. Add the two coefficients together to get the middle one and multiply them together to get the one on the right. So we're going to use that, well, right now for this sum product method. Again, still saying our coefficient is 1 here. Okay, so we can use that pattern we just noticed going from the binomial, the X plus M, X plus N form, and then getting from that to the X squared plus M plus N, X plus N form. But now we're just going to go back and try to use this property and this connection here to work in the other direction. So what we do is we look at, so again, A is 1. That's very important for this. Check that. And then we look at the B value here in the middle and the C value here on the end. And we know we must have this relationship. We're looking for two numbers that add together to give 11, but will multiply together to give 24. So you might be able to see what they are right now, but I'll just kind of show you the process here.
Professor, are you saying weird theorem?
Sorry, tell me again.
Weird theorem?
Sorry,
Or
which?
It's like Wiet's formula, Wiet's.
Sorry, type into the chat. Which theorem? I didn't catch the name. This is not the quadratic Viet. I have never seen that name before. Perhaps that name is used in other countries when teaching math.
Yes.
Maybe I can look that up after. In English, we just call this the sum product method. I've really never seen that before. You've made me curious. I just searched through the textbook, 1,400 pages. That word does not appear. So not saying it isn't, but not something, when this is taught in English, I don't think that word is used. I'll look it up afterward. Okay, so 24, we want a product. So two numbers that multiply together to give 24. So we just look at what the factors are, kind of easy factors of 24.
8 and 3.
8 and 3.
Okay, well, there's an even easier one, like 1 and 24. That could be the solution, so we include that. Let's kind of work down, like sort of do these in order. What would be the next thing that, like after 24, what's the next smallest one or next largest one?
2 and
2
12.
and 11.
2 and 12.
12, yeah.
Yeah. And then the next one, we have 3 and 8, which you guys mentioned. And any more?
4 and 6.
4 and 6. Okay. So we notice that the 24 is positive. So the two numbers should have the same sign, either both positive or both negative. And we notice that the B term is also positive. So if they must have the same sign and the B term is positive, then and B is one plus the other, they both must be positive. So if that's not the case, we would have to consider, well, maybe -1 and positive 24, or positive negative 24, positive 1, like that. But in this case, it's nice and easy, both just positive. So if we multiply these two together, 1 times 24, we get 24. So we have that. So we kind of think, well, if we add them together, what do we get? So 1 plus 24, 25, 2 plus 12, 14, not working. 3 plus 8, 11. That's what we wanted here. So we just kind of, normally you wouldn't write them out. You can just think of what the factors are. But we can use that one, 3 and 8. So it looks like our solution could be x plus 3 times x plus 8. So if we're going to check this, then, and it's a good idea to check if you haven't done a lot of these, multiply the things out and see what we get. So we multiply this out, expand it, we would get x squared. And then x times 8 plus 3 times x. So let's write it this way. 8x plus 3x. So that's 11x. That works. And then 3 times 8, 24. So we got it right. We found the two factors and we have separated them out. At this point, this isn't a question where it says like equals 0. So this isn't like solving for x, but if we did have that, that would just be an easy next step. We'll see some later questions with that. But just in general, like doesn't need to be equal to 0. We can still do this method and factor out without saying that it must be equal to something, or without having like a separate constant on the side or something. So factoring with sum product method, find the two numbers that add to B and then multiply together to be C using this principle here. Okay, let's look at some more and I will let you guys try these ones. So use this sum product method and try to find the solutions for both of these.
Professor,
Yes.
can you back to that question?
Oh,
for
sorry.
one?
I forgot to pause. My mistake.
Thanks.
I was just looking at the Vieta name. The formulas and stuff all look familiar. I think it's just difference of terminology when teaching it. Anyways. Okay, we have solutions from lots of people here. So saying that's The one on the left is x minus 7 and x minus 4. And that the one on the right turns into x plus 8 and x minus 6.
Professor, the variable is y, not x.
Yes, you're right. Y minus 7, y minus 4. All right, so I'll move these down to the bottom and we'll just kind of talk a bit about how we got there. Okay, so same idea, sum product. We notice here, first of all, that with the one on the left, it's positive. So that means that the two things that we're looking for, the two factors, the m and the n value, will be the same sign, because if they're multiplying together and the result is positive, they must be the same sign. But the b value here is negative. So that means that they both must be negative values. So 28, we're looking for factors of 28 here. We don't really need to write the negative signs, but we'll just kind of put them in.
So 2 with 14.
Okay, so 1 and 28, don't forget that one, because again, that could be one of the solutions. So -1, -28 would be the first one. And then -2 and -14. And do we have any other factors?
-7, -4 and -7.
Okay, -4 and -7 here. And it looks like it's. So we just sort of add them together. So -1 plus -28, that's -29. This one, -16. No. But this one, -11. Okay, that's what we're looking for. So those are the two things. There's our -7 and our -4. That's it. All right, and the one on the right here, so rearrange, just so you don't get confused about which thing is the A or the B or whatever. -48. All right, so this one's a little more complicated with the signs. The 48 is negative, so what does that mean about the signs of the two factors?
Plus and minus.
Okay, so they'll be different. One will be positive, one will be negative. And beyond that, what can we see here with the B value being positive?
Like positive value is greater than -1.
Right. So if the B value is positive, two things added together creates a positive number, then the one that's bigger must be the positive one. Okay, so 48 factors here. So 1 and 48, and we said they must be different signs, and the one that's bigger must be positive. So that's a -1 and a positive 48. What are the next pair of factors?
-2 and 24.
-2 and positive 24. I'll just keep the positive for clarity. And the next one?
-3 and 16.
-3 and 16. We can notice here that the B value is just 2. So these things where it's like 1 and 48, that's obviously going to be really far. We want two factors that are going to be pretty close here. But let's just, I'll kind of write some more of these out a little faster here. 4 and 12, and we have -6 and positive 8. And okay, it looks like that's the end there. Let's just kind of check from the bottom because that looks a little faster. Again, we want them to be pretty similar. -6 plus 8, that's positive 2. Okay, there's our solution. So one of these will be -6, x minus 6. The other one will be x plus 8. So the signs on the B and C terms will give you a lot of information about what the signs should be on your factors. Okay, that's yeah, that's it. Sum product method is pretty straightforward. Most of the examples we'll have in class, because I want to focus on the calculus part, not spend a whole bunch of time doing like factoring. They're gonna just be pretty quick to solve using the sum product method. But still, for thoroughness, let's do a bit more practice with a few other methods and see how else we can solve these. So just some little kind of summary notes here. This method, sum product method, is only going to work if the A value is 1. So that's a necessity. Also, it's handy and can be a pretty quick way to find a solution if the solutions are integers. If it's like, you know, a 2 or a 5 or a -3 or positive 20 or something. But if it's like 1.326, not going to work. Like the sum product method, eventually you would find it in theory, but it's like just really tedious. You're not going to want to use this method in that situation. So if the A value is 1, the numbers look easy, then just look for a few factors and see if you can find the solution that way. If you're spending more than a few seconds on it and you don't see it, then go to a different method. Like, don't waste your time. Don't waste years trying to find the solution this way. So it's just a nice shortcut method. It's not always going to work though. That's the strategy with this method. So this was from chapter 6.2 in the intermediate algebra textbook, the earlier one that we had been using for most of the term. They have in that chapter a whole bunch more of these methods. They are all just kind of these shortcut methods. They'll work nicely if your solution is an integer or 2 integers, like whole numbers, but otherwise it's not going to work that well. So I don't want to spend too much time on those. I want to focus on the more general applicable methods. First of those is this square root property, like this. Sorry, that should not say sum product method. Okay, so that should not say. Right. Okay, so something like this first is where we will start, and then 9.2 we'll get to slightly more complex things. So it might be the case if we have a quadratic, so something x squared, but we're just kind of given that and we don't have a separate term. We'll look at kind of some more general cases here and then see, or some specific cases, and then see how we're able to use this information. But let's try this. If we want to solve this one, what can we do? Just starting easy here.
Move 50 on the left.
Okay, so move 50 to the right. X squared equals 50. And?
Square root.
Square root of both sides. So x is equal to what? You can still have the square root, but just tell me what's going to go in front.
Positive or negative.
Okay, so plus minus square root of 50. And we can reduce that a little bit. This isn't a perfect square here, but we can do a little bit with this. So what could we reduce this to? Or let's split it up. Let's-
5 times root of 2.
Okay, so that's the one I was thinking of. I'll just write an extra step here, remind us of our exponent rules. So 2 times 25. And if we do that, we can split this up. So square root 2 times square root 25. So plus minus 5 root 2. Okay. From here, let's just do a little bit more. So there should be 2 values of x, right, as solutions. So tell me the 2 things x could be equal to.
Minus 5 root 2.
Mm-hmm. Or
Just 5.
Positive.
5.
all right, positive 5 root 2. So 2 different versions. Remember, when we see the plus minus thing, that means we have 2 different things we need to evaluate. So those are the 2 possible solutions here. So we'll look at cases where things get slightly more complex, but still not too bad here. Yes, these ones. Okay, so if I have something like this, 3z squared equals 108, how could we solve?
Divide by 3.
Both sides
All right.
by 3.
So z squared is equal to
36.
36. So 36, 72, 108. That looks okay. And then take the square root of both sides, plus minus square root 36. 36 is a clean square, so plus minus 6. So z is equal to 6 or negative 6. All right, still not so complicated. Let's try this one here on the right. What are we going to do first?
Subtract 5 and then multiply both sides 3/2.
Okay, so we'll do those one at a time. So move the 5 over to the right, subtract 5 from both sides. So 17 minus 5, 12. And then we are going to multiply both sides by 3/2 to get rid of this fraction here. So multiplying 12 times 3/2, what will that give us?
Uh,
36.
oh,
12 times 3/2.
19.
Not 19.
18.
There
Yes,
we
I
go.
did.
18.
Okay, 18. All right, so 18 there, u is equal to plus minus root 18. How can we simplify the root 18 part?
plus minus root 3/2.
3/2. I'm gonna skip the step of just writing them separately. We should know plus minus, we evaluate it twice. So 2 different values for u here. All right, one more example in this section, and then we'll go on to completing the square. What do you want to do first to try to solve this one?
Divide both sides by 4.
Okay, so y minus 7 squared equals 12. And then what?
Square root both sides.
Okay, so square root of both sides. I want to encourage you to not, like in this case, if we're trying to solve for y, and we already have it factored like this, you might say, well, let's expand. We don't always want to expand. If we did that, we would get y squared minus 14y plus 49 equals 12. And move this over, y squared minus 14y and plus 37 equals 0. It's solvable, but with this method, like with this, we kind of use our quadratic formula or something. It's a little more annoying. If we already have it like this and we can just get rid of that square very easily, then that's the much easier way of doing things. Having this trinomial where something, the variable squared and kind of something times the variable and a constant together, all three of those is definitely a harder situation to deal with. So if you don't need to expand it, then don't. Here we'll just do y minus 7 equals plus minus root 12. And then just move the 7 over, y equals 7 plus minus root 12. Can we simplify that?
3. Wait.
2.
No, 2 root 3.
Times root of 3.
2 root 3. Okay, so, and then this would be 2 versions, y is equal to 7 plus 2 root 3, or y is equal to 7 minus 2 root 3. Okay, so just because you see an opportunity to expand doesn't mean you should. The goal is to solve for the variable. Getting rid of the square here is the target, so that should be the first thing. If we had a situation like this here, if we could just get rid of the square right away, that'd be great, but we can't. Taking a square root of this would give us root y, and then we're not any better off. That doesn't help us. Okay, so still some simpler ones. Let's look at completing the square. So we'll do this and then quadratic formula. We're good for time, so we'll keep going with this a bit. I want you to be aware of a pattern first before we actually start looking at these. So let's try this one over here on the right. So now let's actually expand. I want you to see what the pattern is when we expand something like this. So x plus 9 squared is equal to what?
X squared plus 18x plus 81.
Plus 18x plus 81. So let's just talk, or let's move this down. Let's just throw in a few more steps here. So x plus 9 squared is x plus 9 times x plus 9. We are multiplying each thing on the left one times each thing on the right one. So x squared plus this x times this 9, 9x plus this 9 times this x, 9x again, and then 9 times 9 gives us the 81, and then we see the 18 here. All right, let's do the next one in the middle. We'll skip this step, but tell me what this step would look like for the one in the middle.
X squared minus 2x multiplying 7 and plus 7 squared.
You said 2x?
Yes. 2x multiplying 7, then plus 7 squared.
I want it to look like this step here on the left. Give me the equivalent of that for this one.
Negative 7x minus 7x.
Okay, so minus 7x again. We're going to end up with 2 of them. And then
Plus 49.
plus 49. That's the 7 squared there. And then this is x squared minus 14x. 2 times 7 plus 49. Okay, so hopefully we're kind of starting to see a pattern here, and it should become very obvious with this one on the far right. So one more time, I want this version of it and then the other one afterward. What's the first line?
Squared.
X
Okay.
squared.
X squared
plus xm plus xm.
plus, I'm going to write it as mx plus mx plus
Plus m squared.
m squared. And here we're sort of saying m would be some constant. X is the variable we're trying to solve for, and m would be some constant that we are given in the problem. Then if we simplify this, just x squared plus 2mx plus m squared. So that is the pattern that we can notice. If we have just, these are called binomials. So something plus something, like just two terms, and then squared, we are going to get this pattern. If the simpler case here, if our x is here, if there's no coefficient on the x. So the m, whatever that is, it will be 2 times that for the b value, and then that thing squared for the c value. Not too different how we had the n plus m for the b value before, and the m times n for the c value here. Okay, so that's the general pattern, and then we are going to use that to complete the square here. So let's start off with this example and see how we can do this. So completing the square, some of you, I'm sure, know this or remember it. Can you tell me what we would do here?
We can move 48 for left side of equation.
We could, that doesn't actually matter. That's not really going to do anything for us. The completing the square method, that's not necessary.
We can use brackets like x. We can open the bracket and x plus 8 and close the bracket.
Okay, so you want to factor out x plus 8 like this. Okay, how does that help us solve? That's some factoring, but that doesn't help us solve it. Okay, I'm sure when I show you completing the square, a bunch of you will remember it, but maybe it's just you haven't heard that term for it before. So we're going to use the pattern that we saw before, where again we had x plus m squared equal to x squared plus 2mx plus m squared. But like we did before, we're going to go from the bottom one up to the top one, try to work backward like that. So what we want is to create a nice, clean, kind of perfect square here with a binomial. So I want x squared plus 8x plus something. And the 48 is still going to stay there over on the right. But I want a something that's going to make it look like this so that I can change it into this thing on the top. Can anyone tell me how we could do that?
16 maybe, because we need 4.
Okay, so where's the 4 coming from?
8x equals 2 multiplied by mn.
Okay, so if the b value it's 2m, then m is just half of the b value. So in this case, our m would be equal to 4. So we take our 8s divided by 2. So we've done that. 8 divided by 2. Sorry, 8 divided by 2 is 4. And then the c value here is that squared. So 4 squared, 16. And that is going to go here. So now we've completed the square. And now we can do the thing that we have on the right here and go from the bottom one up to the top one. So what is the next line of this thing going to be? What do we have on the left?
X plus 4 square.
X plus 4 squared. So let's just kind of write this out and just sort of prove to everyone, convince everyone that this is actually true. So x plus 4 squared is x plus 4 times x plus 4. So that's equal to x times x, x squared. X times 4, 4x, x, this other 4 times this other x, 4x, and then 4 times 4, 16, simplify x squared plus 8x plus 16. So this is what we had up here. That's where we, that's the perfect square that we made. We've completed the square. We completed this thing. We had an kind of a x plus something squared. We wanted to make this, and that's exactly what we've done. So find the constant number that will complete it. And now we've completed the square. We haven't solved yet. That's the first step. So what can we do to actually solve this problem?
We can add negative 16 because we have add positive 16, right?
Oh, yes. I apologize. Yes, I forgot about that step. Let's add that here. Plus 16, and then that's 48 plus 16, 64. Thank you for pointing that out. I forgot about that. Okay, let's try that again. Now, how can we solve this?
We can solve square root of 64.
Right, so exactly what we saw a moment ago, where we can just now do a square root. That gets rid of our square. Then this becomes much easier to solve. It's just x equals something, no more x squared. So square root of both sides, x plus 4 equals plus minus square root of 64.
8.
8. Okay, and then if we have this, a little more work now to solve it. So x plus 4 is equal to positive 8. Therefore, x is equal to 8 minus 4 is 4, or x plus 4 is equal to negative 8, and move this over. X is equal to negative 12. So now we have solved it. If we want to check our solutions, just like all of our previous cases, we can take these numbers and substitute back into the original and make sure it works. So 4 here, 4 squared is 16. 8 times 4 here is 32. 16 plus 32, 48. That works. Negative 12 squared is equal to 144. And then negative 12 times 8 is 96. Yes, so 144 minus 96, 48. So yes, it works. Both of these our solutions for x here. Again, because it's an x squared, we're going to have two different values that are possible solutions. Okay, so that's the completing the square method. Remember the thing that we have on the right here, x plus m squared is equal to x squared plus 2mx plus mx. We just want to go backward. So find the number that we can put in there that will let us go backward with that one. Let's do one more of these examples and then we'll take our break, and then I'll have a few more and then we'll switch to the quadratic formula. So I'm going to erase this. Let's hope everyone has what they've written down, what they need. All right, and let's do this one here. Okay, so what are you noticing? What can we do with this? All right, completing the square method again. You want y squared minus 18y and then plus or minus plus something here will equal -6, and then we'll have to also add that same thing. So this is the square that we are trying to complete. So what number can we put in there?
81.
81
9.
or 9. Okay. One of those two. So again, we want, or sorry, tell me the method that we're going to use to find it.
Like 2m equals 2my equals -8y, right? And m.
Okay, so let's talk through the method, like kind of step by step. What's the first thing that we notice, or first thing we should be looking at?
M is 9.
Okay, so tell me how we are getting there.
Divided by 2.
Okay, so we take this, if our b value is -18, b over 2 is equal to -9. So then what should our c value be?
81.
81. So we're taking our c is that kind of b over 2 squared. So our -9 squared, which is 81. So 81 is the number that we write in here to complete the square. We also need to add 81, as I forgot in the previous example, to the other side here to keep everything balanced. Otherwise, we are not going to get the right solution. Okay, so if we've completed this square, then what's the thing? What's the square that we are going to have?
Y minus 9 squared.
Okay, so in this case, it's y minus 9 because we had -18 here and not +18. Remember, that number is coming from -9 times 2 should be equal to this thing, the b coefficient here. So that's -18. And on the right side, we have -6 plus 81. So that's 75. All right, I am going to skip the step of sort of checking that we have done the complete the square correctly, because we have. Also, we did that in the previous example. So I'll leave that for you if you want to check it. What's the next thing that we can do here?
We can get rid of square.
Okay, so get rid of the square. That was the whole purpose of this. That makes it much easier to solve for y. So y minus 9 is equal to square root. Sorry, I forgot the plus minus square root 75. Okay, well, we can just move the 9 over. That's easy. Plus minus. Can we simplify the root 75 at all?
5 root 3.
5 root 3. So 75 is 25 times 3, 25. That's a nice perfect square there. So that is square root of 25 would be 5. So 5 root 3. Okay. And then we have our two values of this. So y is equal to 9 plus 5 root 3, whatever number that turns into, or y equals 9 minus 5 root 3. And I know we have these square roots in the solution, but still, if we put these in to our original equation here and multiplying everything out, it would work out. We would see that we get rid of the square roots are going to disappear, and we're just going to end up with this -6. Again, that process here, I'll just skip that checking process, but we can always do that and substitute these back into the original to check. Okay, that's the completing the square method. Okay, we'll have a few more examples we'll do after the break, but does anyone have questions about it right now that they would like to ask?
I have one question.
Sure.
I want to ask about intervals and x-intercepts.
Okay, let's start the break time, and then you can ask me during the break time, and then after we'll come back to these examples. So what time do we have? 8:34. So we'll start again at 8:44, everyone. So take a break, and I'll see you then. What was the intervals and such? So.
Can I ask?
Yep, go ahead.
Are they always the same? I mean, is it always intercepts are equal to x-intercepts? Intervals equal to x-intercepts?
No. Let's go back. I closed those other slides, but let's go back there. Which one will help? Okay, this will work. Okay, so let's think of some cubics. That'll be easy enough to show. So a cubic could have, as we showed in class, a cubic could have this shape. Let's do a little less. So a cubic could have this shape, and it could have this shape where it goes perfectly flat to 0 and then up. And it could have this shape where it never actually hits 0. It's just constantly increasing. Sort of a bit of a wave to it, but still increasing the whole time. So this one on the far right will always have one interval and 1 0. The one in the middle, sort of a special case, but let's think about the one on the right here. So this is one version of it. And let's move this over. Currently, with how it is right now, how many intervals and how many zeros do you see?
3 zeros, 3
Okay.
x-intercepts, and 3 intervals.
All right. And what about now?
1 x-intercept, 1, 0, and 3 intervals.
What about now?
The same.
Okay, there's your answer. So if we're going to have sort of the maximum number of intercepts, then we should have all of the intervals, first of all, and each of the intervals should kind of very conveniently be crossing the x-axis like this. But if the intervals are kind of doing this stuff up here and they just happen to never touch the x-intercept, then it's not gonna make a 0. The number of zeros cannot be more than the number of intercepts. So they can be equal, or there could be more intervals, but zeros cannot be more than the number of, sorry, I said intercepts first. The number of zeros cannot be more than the number of intervals. They could be equal, or there could be more intervals.
Thank you, Professor.
You're welcome. All right, let's resume. So break is always a little longer than what I intended. 4 more of these completing the square examples. I think I'll just do 3 of them, and then we'll move to the quadratic formula stuff. So this one here, if we're going to do our completing the square, what should come first?
Maybe get rid of the 4.
Yeah, so we're going to have kind of x squared plus
Or we can add 21 to the end.
Okay, so yes, that'll work. I'm just going to keep it with sort of the more straightforward solution. The numbers are going to work out the same anyways, and it really is just like one tiny little extra step. So let's get rid of the 4 because we are going to want to have x squared plus 10x plus something equals 15, move over the 4, so 11, and then plus that same something. What is the something that we would put in here?
25.
25, so 10 over 2, our b value over 2. B over 2 is 5, and then we just square that, and that will give us our c value. So that's 25 and 25 here. We already had a 4, which is why we heard the suggestion, like just add 21, but whatever, it's not really that different. So the right side here, pretty easy, 36, and looks like that'll be a nice clean square root in a moment. What about the left side?
X plus 5 squared.
X plus 5. So that's kind of the m value that I was saying right here, the b over 2. It's also square root of c. It's both of those things. So there we go. That's x plus 5 squared equals 36. Just do the square root of each side as before. X plus 5 equals plus minus square root of 36 is 6. So x is equal to, I'll write it this way, -5 plus minus 6. So here, no weird square roots or anything. We can get some actual numbers. What are the 2 possible values for x?
1 and -11.
Okay, so we have a -6, so -11, or we have a +6, so 1. And those are the 2 answers.
Professor,
Yes.
I'm a little bit confused in the second step, which is x plus 5 square. How did you like make it like this?
This, okay. So
Yeah.
that's the, remember we looked at that pattern, and x plus m squared. If we kind of work that out, x plus m, x plus m, so x squared plus 2mx plus m squared. So we're remembering this connection between this thing and this thing. And we are just sort of working backward. So we added 25 here so that this is the same as this bottom part. And then we realize, oh, it's this special type with the 2m and the m squared. So we can go back up to the binomial, the x plus m squared. And that was this thing here. So it's easier to think about when we go in the opposite direction. If I gave you x plus 5 squared, we could just do the multiplication and realize that it's x squared plus 10x plus 25. But we've done that a bunch of times. We recognize the pattern, so we can also recognize it in reverse and use that. So that's what we used.
Thank you so much.
You're welcome. Okay, that's the solution. Next one. All right, here. So some rearranging to start. How can we rewrite this?
Subtract 3n to both
Okay.
sides.
So n squared minus 3n equals 11. And let's just put that step in here. So plus something equals 11 plus something. What's our something here?
9/4.
9/4. Okay, so we have our b value. B is -3, and we want b/2 to be our m value. So that would be -3/2. And so that's kind of the quote unquote m value. Normally that I'm just saying like quote unquote m because that's not the standard term used. I've just kind of made that up to help explain it. So -3/2, and then we want that squared. -3/2 squared. -3 squared is 9. 2 squared is 4. So it looks like 9/4 here. 9/4. And then on the other side, also plus 9/4. Okay, so then on the left side, if we factor that out and sort of we take our perfect square and rewrite it, what will we get?
X minus 3/2 squared.
Okay, so n for
The
our
n,
variable.
sorry.
That's all right. -3/2 and that whole thing squared. So don't forget the negative because it's a negative here for the b value. So b/2 gave us a negative value. So n -3/2 squared. So we can just fractions, so we don't want to get confused. Just take this thing squared 9/4. Okay, that matches there. And also this thing times 2. 3/2 times 2 is just 3, -3. So works out there as well. On the right side, how can we simplify this? Let's have this as just a fraction, something over something.
13 and 1/4.
Something over something. Just I want it
Ah.
just as a fraction, not a mixed fraction.
50/4.
I didn't hear the second number. 50 what?
3/4.
53/4. So the 11 is going to be 44/4. 44 plus 9, 53/4. Okay, so square root of each side, n minus 3/2. Square roots plus minus square roots, 53/4. Can we, the square root of 53/4, can we simplify that in any way?
Not really.
Yes, we can.
Square root 53/2.
Okay, so square root of 53, 53, pause, so end of square root, then over 2. So remember 53, or 53/4, we can split that up into 53, square root of 53 over square root of 4, then just reduce the square root of 4. Okay, and then we just have the two versions of n. It's this one or that one with the plus and with the minus. We've done that a bunch of times. I'm going to skip that part here. Okay, so even if the C value that we end up adding in, it's a fraction, it's all right. It's still handleable. We have a square root thing, but doesn't work. Doesn't matter. We'll just leave it as a square root. Don't need to write the actual number. The next one, I think, is the one I decided I'm going to skip for sake of time. Right. So it's kind of the halfway step, and then I just want to get to the slightly harder one here. Okay. What could we do with this one?
You can divide both sides by 2.
Okay, so we kind of want the x coefficient to just be 1 here. There are other things that we could do, but it's not going to turn into a nice clean square, and we'll get some weird stuff that's going to make it a bit harder. The much easier thing is just divide both sides by 2. So x squared minus 3 over 2x equals 20 over 2, 10, like this. All right, and then we just do our whole complete the square method here. So let's do that. What would our term be? What are we adding here?
9 over 16.
9 over 16, 3 over 2 divided by 2 is 3 over 4. Square that gives us 9 over 16. Sorry, that's negative and that's negative, but then they become positive there. So 9 over 16 and 10 plus 9 over 16. So the next line, what are we going to get on the left side here?
X minus 3 over 4
Okay, so
squared.
x minus 3 over 4 squared. So that's the negative 3 over 4, just our b value divided by 2. And on the right side, give me this just as a fraction.
169 over 60.
169 over 16 here. Okay, so the 10 would be 160 over 16 and then add 9 there. Also nice, square root of that is going to work out pretty nicely for us. 3 over 4 and square root of this, 169 over 16 plus minus. What is that? 169 over 16. Sorry, the
13
square
over
root.
4.
4.
Okay, 13 over 4. 3 over 4 plus minus 13 over 4. And if we work this out, we have our 2 solutions. So x would be equal to what things?
4 and negative 2.5.
Okay, so negative 2.5, I'll write it as negative 5 over 2 here. So 4, 3 over 4 plus 13, 16 over 4, that's 4, and then subtracting here, so 3 minus 13 here, we'll get negative 10 over 4, and then negative 5 over 2. Okay, that's completing the square. So even if you have a coefficient here on the x squared, just divide and get rid of that. And if you have whatever, excuse me, whatever constant just kind of off on the right side, ignore it, add in the number that works for you to complete the square. You just have to look at the b term and then that's it. Okay, so any questions about this method, completing the square? Okay, I know I'm going pretty quick through these. These are the example questions or some of the example questions that are in our textbook. I'll show you the list of the textbook sections again. There's lots and lots of practice questions that you could work on for these. And the last part here, quadratic formula, your favorite formula. So it's here on the slide. I asked you to, I kind of made everyone try to remember this during class time, but now I'll just give it to you here. So remember, it's for this situation. If we didn't have the equal 0, then we can't make this assumption. If we say that it is equal to 0, then that's when this thing is going to work here. So if we have this, then we can do this. In your math classes, B plus minus squared minus 4ac over 2. Sorry, Mirabos, I'm just looking at your comments here. Over 2, are you not including the over 2a? Yeah. What you've written is the same as what I have here. Yeah, okay. All right. Sorry, you sent your message quite a while ago. No, you sent it just now. So I'm not sure what you're asking with your question, because what you've written looks the same as what I have here. Okay, so this is the quadratic formula here. I am curious, in your math classes, did you see like where this comes from? Like, did you actually see a proof, or did they just tell you memorize this thing?
They did, but I forgot.
Okay. Anyone else? If you forgot it, that's fine. But I'm just, were you shown, like, given an explanation for this, or? Okay, Mirabos is saying just memorize. Anyone else want to let us know? Okay. The method is, it's actually not that hard. You just take this thing here, ax squared plus bx plus c, and complete the square. That's it. The method that we just did, you do the exact same thing, but except with variables here. So we would be adding kind of b over 2, but then that whole thing squared. So that's, you know, b squared over 4. And then we add that to both sides, and then we do the complete the square thing, convert it into a binomial, and then just keep rearranging until we have completely solved for x. And the result is the thing that we have on the right here. So the completing the square method that we just did is exactly how we get this formula. So when you're using quadratic formula, basically you are doing complete the square, but without kind of the clever thinking, you're just letting the formula do the work for you. Okay, so we'll just, there's the formula, write it down if you don't remember it. Also, the derivation of this, the proof of this is in our textbook. This is section 9.3 of the intermediate algebra textbook, right at the beginning. They have the whole thing. Looking at it right now, page 911, 912. It's a bit long, so I'm going to skip it here. But if you're not convinced, or you have no idea what this thing is or where it comes from, it's nice to just look at that and kind of see what exactly the logic is, what the reasoning is behind using it. Okay, so let's go on. And I have a few here. We're just not anything especially complicated. We just use the formula. So let's do the first one together, and then I'll let you guys work on the other ones. Sorry, something in my eye. All right. I just had the formula there, and now I don't have it. Can you remember what it is? Can someone tell me?
Minus b
Uh-huh.
plus minus,
Uh-huh.
like inside the root
Square root.
b squared
Uh-huh.
minus 4 multiplied by c.
AC. We're not done.
Divided by
A.
2a. 2a here. So remember ax squared plus bx plus c. That's how we know which part goes where. All right, so if we have this, then our x will have probably two solutions for our x value. So -9 plus minus square root of 9 squared minus 4 times 2 times -5. And all of that over 2 times 2. All right, -9 plus minus square root of 81. I don't feel like writing that all out a bunch of times. Let's just do that on the side here. 9 squared minus 4 to -5. 81 minus, what will this other part work out to?
45.
45.
No, it's negative 40.
40.
40, okay, and plus, are we positive or negative?
Positive.
Positive, so negative, and then the -5 here, that's going to turn it into a positive number. And that is 121, and then we're very happy because that's a nice clean square root. And over 4. So -9 plus minus, what is that square root?
11.
11 over 4. And that means we have, gonna kind of run out of space here. Let's move this up. And over. So x is equal to -9 plus 11 over 4, or x equals -9 minus 11 over 4. On the right here, what do we get?
1/2.
1 over 2. So we get 2 over 4, reduce it to 1 over 2. And on the right, what do we get?
-5.
-5. So -20 over 4, -5. So there are the values for x. Like usual, we could sub them in and verify our solution. I'm going to skip that part. Okay, so it's a formula. I don't know. I never see much point to doing tons of practice with formula questions because you just throw the numbers in the formula and then that's it. Just do some algebra. But we'll do a few of these here and then that'll be it for today. So I'm going to erase the formula. I really hope you have it. If you didn't remember, I hope you have it now. And try to solve. You can write your answers in the chat when you have them. All right, we got 3 answers in the chats, all the same. So just rewriting. Actually, no, let's not rewrite. Just tell me, what is our A value?
1,
1. What is our B value?
-6,
And C?
5.
5, positive 5. It's got to be on the other side. Remember that form ax squared plus bx plus c equals 0 is very important. So we have to rearrange this to x squared minus 6x. Well, don't need to rearrange, but understand that this is the form we are looking at. So positive 5 going into your formula, not negative 5. So the answers you guys have in the chat are right. I'm not gonna try to do this without writing out too many steps here, just for expediency. So negative b, so that's just 6 plus minus square root of b squared. So negative 6 squared is 36. And then our 4ac minus 4ac will be 4 times a. So that's just 4. And then times c here, which is 5. So 20. So 36 minus 20 and over 2a. So just over 2. So x is equal to 6 plus minus 36 minus 20 is 16. Square root of that is 4. 6 plus 4 over 2. And 6 plus 4 over 2, or x is equal to 6 minus 4 over 2 and 1, 5. Okay, I got one more of these with some roots in it. I'll just give people a moment in case they are writing. While I'm giving people a moment to write, what would happen if our square root b squared minus 4ac? What happens? It's a square root. So what happens if this thing ends up being equal to 0? Or sorry,
We
ends
have
up being
only-
negative.
Or we have no solution if it's negative.
Sort of. If we kind of do like middle school sort of math, then we'd say, hey, no solution, just stop. If we are kind of doing some higher level math, what would we say?
Take out the -1. So like, because it's an imaginary number, right?
Okay, so the imaginary number square root -1 equals I. So it's an imaginary root. Imaginary, but does actually end up having lots of practical applications in like quantum physics and stuff. So if you put it on a graph, then you wouldn't see a root there. It would be something like this, and it just never touches the x-axis. So that's the visual sense of it. So it means no real roots. If you graph again, it's not going to touch. But in some cases, we do care about the imaginary numbers. So we just take out the root -1, rewrite it as I, and then do the rest of it and just write it with that I variable in there. I term in there. Okay, that's enough time there. One more. You're going to have some roots. If you want to write your answers in the chats, you can write them SQRT of like whatever the number is, like that. In programming languages or in Excel formulas or whatever, that's how you write square roots. So you can use that to write your answers. Go ahead. Vincent, it is possible to reduce your answer a little bit, to simplify it a bit more.
It's just annoying to type it out.
No, I mean like mathematically, there's a common factor you can take out.
Yeah,
So-
I know, but I'm going to retype it, but it's annoying to retype my answer.
Just copy paste.
Okay, okay.
Okay. You don't need to. I just, if you realize what it is, that's fine. All right. So just run through these. A is 2, B is 10, and C is 11. So formula X is equal to -10 plus minus square root 10 squared, 100 minus 4 times 2 times 11, 4 times 2. Let's make sure I get this right. Yeah, 4 times 2 is 8, and then times 11, 88. And on the bottom here, 2a, 2 times 2, so 4. -10 plus minus square root of, just so I don't have to rewrite all of that. This is -100 minus 88 is square root 12. And we had this before, but tell me again, how can we reduce the root 12?
It becomes 2 root 3.
2 root 3. So 12, 4 times 3, and then square root of 4, 2 times 3. So 2 root 3 over 4. We can see we have a common factor of 2 on the top. I guess we could write this out. 2 -5 plus minus root 3, and that over 4, and then just reduce. So -5 plus minus root 3 over 2. And the two versions, the plus and the minus version, I will skip writing those out here. X equals something, or X equals the other something. Okay, so that's the formula. I always think the formula questions are boring. There's no challenge. There's no excitement to them. But good to do some practice. Anyone have questions about quadratic formula? Going to give people another just moment if they're writing something down, and then I'll jump back to the sort of plan slide and show you the textbook sections. All right. While people are writing, what are the methods that we looked at today? Let's see if we remember. What was the first one?
Some product method or something.
Yes, sum product method. So find the two numbers that add together to give B and multiply together to give C. It's only useful, only can be used when A is equal to 1. And it's only really useful if the solutions are integers. So it's just a nice quick shortcut method. Use it and see if you have a solution, if you can see one really quickly with it. If not, use a different method. So that was first one, sum product. What
So
was, sorry, say it again. What was the next one we talked about?
factoring trinomials.
Yes, so the factoring the trinomials. So we had, if we have just an x squared and then kind of a constant, if we don't have an x squared and an x and a constant, we just have kind of two of them. We just do a square root of both sides. Get rid of the square root. That was the target there. That was the goal. And then we had a third method just before this one.
Completing the
Right, completing the square. So that's if we do actually have all three parts. We have an x squared and an x and a constant. We can't just factor something out. We can't do a simple factoring. We can't just take a square root. We have to do kind of the fancier version of it. We complete the square, add in some extra constants value that lets you find a perfect square and x plus something then all squared, or x minus something all squared, or quadratic formula. Just use the formula. For our purposes in class, it's most of the examples I will talk about in class and homework and stuff. You're just going to be able to do sum product method pretty easily, or there's like another kind of shortcut method you would notice pretty quickly. Quadratic formula will always work. If you're stumped and you can't see the solution, you can throw things into the formula and you'll get your results. But it's nice to know other methods as well. So if this is totally new for you, I want you to learn sum product method because it's very quick and we're going to use it a lot. And I want you to learn quadratic formula because it's the most versatile and the most reliable. So those two, absolutely. The other methods, and then there are more methods in the textbook as well. That's up to you. Okay, so I've had the textbook, the chapters kind of listed. But we'll just write that out here. Again, I would normally like write out the actual specific questions we went through. It's in the recording. I'll post it a bit later on our classroom page. But chapter 6.2 had a bunch of these shortcut methods that we, like that sum product method that we saw, and it has some more, but they're kind of just like clever things, and they're only really going to work or work nicely if you're dealing with integers. If you have solutions like we just had, like -5 plus √3/2, you are never going to find that with some shortcut method, not in 100 years. So that's why these other ones are a little more powerful, a little more flexible, a little more important to learn. So if you have just the if you can take a direct square root, then that's using this sort of square root property. Chapter 9.1's got a bunch of those. If you have actually like all three of them, 9.2 has completing the square and a bunch of examples. And also, if another way, if you have all of them, chapter 9.3, which I mentioned, is actually just completing the square. It's just a formula version of it because that's where the formula comes from. That's my advice for you for dealing with these quadratics. Common problem. We have a something squared plus a something plus a constant. Find out what the something is. That comes up a whole lot. It's essential to be able to know how to solve those. Questions about these, I see some people have written me in the chat other questions. Does anyone have questions about these methods or solving quadratics? Nope. Okay, then I think we are done. So you guys are free to leave. Some of you have questions. You wrote me in the chat, so just hang around and we'll talk about them. Otherwise, enjoy your evening. See you in the next class.